Guys, we are going to use some really fun theorems and stuff. One of them is the triangle inequality theorem. Okay. We are also going to classify triangles by angle measures and side lengths. Then we're going to use the triangle sum theorem, super fun, and the exterior angle sum theorem. Jeez Louise. All right, recall that a triangle is a polygon with 3 sides. Do you guys know what a polygon is? It's a shape. Okay, so question, is this a polygon? Okay, so the sides have to be straight. Do you guys remember this? So this is not a polygon. What about this? Is that a polygon? It's got to be closed. Okay, so the sides are segments and it has to be closed. So neither of these are polygons. Yeah. Okay, we'll talk about that more later, but just so we know, that's what it is. Okay, so we have sides AB, AC, and CB for triangle ABC. And the points A, B, and C are the triangle's vertices. All right. We're going to watch a little video. I will just link this video so that you don't have to watch it on this video. I can't guarantee the sound quality. So we need to make sure that the sum of any 2 side lengths for our triangle is greater than the third side. Okay. So we did a couple of these with the video, so these should be very simple. Just take 2 seconds, check each of them. Remember, we only need to test the 2 smallest sides added together. You're welcome to test it periodically. Okay. All right, what do you think for the first one, 7, 10, 19? No, because 17 is not greater than 19. All right, what about 8, 13, and 21? No. Okay, because 8 and 13 add up to 21, and 21 is not greater than itself. Oops. We'll do 12. All right, last one? Yes. Okay, because 2 and 16 add up to, which is, so this is the only yes. These others are no. Okay. Now, we only have to check the smallest 2 because look, 10 and 19 added together are obviously bigger than 7. 19 and 7 are obviously bigger than 10. So we really just have to check the shortest 2. All right, triangles can be classified in 2 ways, by their angle measures or by their side lengths. Not by their hairdos. It's not a thing. Triangles don't have that. All right, in order to be acute, all of the angles have to be acute. So we've got to have 3 acute angles. All right, what about this one? Yep. Any idea what those angles would measure? Do we know yet? Okay, their sum is 180, so each one has to be, do we know? 60. Yeah, each of these bad boys is 60 degrees. Okay. What about a right triangle? Yeah, we can only have one right angle. There's only 180 degrees for the three angles to share amongst themselves, so we only have enough degrees for one of them to be a right angle. Notice it doesn't matter that these other two angles have to be acute. They have to be acute because they only have 90 degrees to share between them. Okay? So in order to be acute, it has to be all three that are acute. All right, similar with the obtuse. It just needs one. The other two angles have to be acute. Okay. So we are just classifying each triangle by its angle measures. The hardest part about this is this tiny little baby picture. What I'm seeing is that angle A is 80 degrees. Is that what you guys are seeing? Okay. So if I'm looking at angle ADC, which is this guy, how would you classify that one? It's right. Oh, did I say angle? I meant triangle ADC. Sorry about that. It's a right triangle. Oh, bad. Okay. What about triangle ABD? Yeah, I agree. It's this little baby one. It's got all those acute angles in it. Okay, triangle BDC. Which one? Yeah, BDC, yeah, obtuse. Sorry. I don't know if you guys believe me, but it's a little bit disorienting when your face is so close to the board. Like, just try putting your eyeballs that close to your paper. It makes you at least 20% dumber, as a rule. Or it does to me. All right, classify each triangle by its angle measures. So triangle EHG. EHG, that's the big one. Yeah, it's right. Okay, triangle FHG. FHG. Yeah, it's equiangular. Okay, what about triangle EHF? Obtuse. Okay, before we go any farther, find an open space. We're just going to make a little observation. Nope. Okay, I'm just going to draw my own. Okay, can we number our angles? 1 being the smallest, 3 being the biggest. Try to draw this picture as much as you can. Which is the smallest angle? This one or this one? Because again, don't look at the side lengths, look at how big the mouth is open. Do I need to redraw the triangle? Okay. I'll draw it. This. Make it, is that more obvious? Yeah. Okay, which one is the smallest one? Smallest angle. The one on the left. Okay, so this is the smallest. Okay, which is the smallest side? On the right. All right. Some of you do not have this written down, and I'm nervous for you already, because this is going to be very important for the rest of your life. But I don't know that it's anywhere written down ever. It probably is. Okay, which is the biggest angle? We'll give it a 3. The biggest. The one on the bottom. Okay, which is the biggest side? Yeah, the top slanted one. Are you noticing anything fun? Oh, there we go. All right, and then obviously, this is the middle angle, and this is the middle side. So, what do you notice about my smallest angle? It is what compared to my smallest side? Okay, so do you see how it's across? We call that opposite. Are you seeing what I'm seeing? Each of my smallest angles is across from opposite. Okay, my smallest side is opposite my smallest angle. My middle angle, middle side are opposite each other. Does everybody see it? So you can think about it like the bigger we open our mouth, the bigger the side is going to have to be to close, like to cover it, right? The bigger the mouth, the bigger the side to cover it. Tiny little mouth, tiny little side. Big mouth, big side. Everybody got it? Okay. All right. Triangle classification by side lengths. Now, if all 3 of my sides are the exact same length, what do you think happens to all 3 of my angles? Yeah, we're all the same length too. So any triangle that's equilateral is also equilateral or equiangular. I said the same word twice. Oh my gosh. Okay, so obviously there are 3 congruent sides. So if you want to go back and add that to your equiangular triangle, that it's also equilateral. That'd be a good idea. All right. What about isosceles? Yeah. So, does it say exactly 2? At least 2. So here's the fun thing. If we draw a Venn diagram of triangles, okay, in the isosceles bubble are the equilateral triangles. Oh shoot. I'm just trying to draw a circle and my brain will not let me do it. Okay, so these are the equilaterals. So every single equilateral triangle has at least 2 congruent sides. Therefore, every single equilateral triangle is also isosceles. Okay? Is that okay? Are all isosceles triangles equilateral? No. So we've got some isosceles that are not. Okay, now it's time to think about like the bigger the mouth, the bigger the side. What if my 2 sides are exactly the same length? What can I infer about these 2 angles? Yeah, they're also congruent. Now, we'll talk about this later, but it has a name, and it's called the base angle theorem. Okay. Okay. Scaling. 0. None. Yep. Correct. Yep. Yep, that'd be weird. All right, here we go. Let's do some classifying. We can't assume. When we look at a figure, you can't assume that segments are congruent based on how the figure is drawn, on how it appears. The figure may or may not be drawn to scale. The sides have to be marked as congruent. So if I draw you a beautiful, what looks like isosceles triangle, it might not be isosceles. It's only for sure isosceles if it's specified in writing or if it's marked where the sides are congruent. Is that clear to everybody? We don't get to assume just because it looks like it. All right. All right, what about triangle EHG? We've got a 10, 11, and a 12. Are any of them congruent?
No.
No. So, scaling. All right, what about EHF, triangle EHF? Yeah, it's isosceles. We know because the two sides are marked as congruent. Also known as the most impossible to spell. It's the SC combination in the middle of the word that fries my ears. All right, what about triangle FHG? That's the little one. This one. So I've got a 10, a 4, and an 11. Yeah, scaling again. All right. You guys want to try this one? Test yourselves and then we'll talk about it. Which one did you change? B? All right, let's change this one to a C. All right, what did you say about triangle ABD? Yes. All right, what about the next one? Good. Woo! Hold on. Yeah, well, it's both. So we can write both. I heard someone saying something. What are you saying? Okay, but you're not wrong. But our definition of congruent says that if sides have the same measure, if segments have the same length, then we know that they're congruent. Okay, so if this didn't have anything, we wouldn't be able to assume, right? But if it's marked as the same length, then we know by the definition of congruent. Okay, so we can also say equilateral. Okay, if you can only pick one, you have to pick the most specific. Does that make sense? If it's like a select all that apply, it's both. If you have to pick the most specific, you pick the most specific. What about triangle ACD? Yeah. All right. Triangle sum theorem. I think we might already know this. The sum of a triangle's interior, I don't know why that space is so big. Interior angle measures is 180 degrees. So we know that the measure of angle A plus the measure of angle B plus the measure of angle C is 180. Okay, using the triangle angle sum theorem, find each angle measure. So we want to know the measure of angle XYZ. XYZ. So I only have 180. I've already used 40 and 62, so those have to be taken away. What's left? I use 78. I don't have a calculator. Am I going to feel dumb if I write down 78? Someone check for me. Who's got a calculator? Okay, what about the measure of angle YWZ? YWZ. Okay, we already found out that this one is 78. Thank you for your assistance in that matter. So, if I look at my big triangle, I know that this angle here is a 78 plus a 12, thanks to my angle addition postulate. That makes 90. Is that one of the ones I have to find? No, it's not one of the ones I need to find. Okay, so I still have to find YWX. But now I know I've got 40 and I've got 90 used already. So I'm getting 50. So we're doing 180 minus 90 minus 40. Which is 50. 50. Okay, last one. WXY. That's this one. The big obtuse angle. I think that was right. Will you say it one more time? Yeah, 118. So you can take your 50 and your 12 and subtract them from 180 and get 118. Or you can say, look, it's in a linear pair with 62 degrees, right? Either way, it's 118. Sometimes there's more than one way to find an angle. All right, this we already know. An auxiliary line is a line that we can add to a figure in a proof or a construction. I'm pretty sure that's how it's spelled, but you might want to fact check me with Google later. It feels like there should be two L's, but I don't think there are. Yeah, it comes from French. It has like the French root for like helping. I think it comes from Latin. All right. So the triangle sum theorem has some little corollaries. Corollaries are little logical consequences of our theorem. They're little logical extensions that we can use to our benefit. Okay, a corollary is a theorem whose proof follows directly from another theorem. So, because of the triangle sum theorem, The acute angles of a right triangle are, oh, I know what this is. Okay, how many degrees do we have for the interior angles of a triangle? Okay, we've already used 90 on a right angle. How many are left? 90. What do we call a pair of angles whose sum is 90? Starts with a C. Correct. Okay, so we know that the measure of angle D plus the measure of angle E is 90 degrees. That one is cute. All right, what else we got? Oh, we already know this one. We talked about it. If a triangle is equiangular, that means they have to share the 180 degrees evenly. Okay, everybody gets the same size piece. So I just take 180 divided by 3, 60 degrees. So the measure of angle A equals the measure of angle B equals the measure of angle C equals 60 degrees. Okay, so this is kind of a like, well, duh. The interior is the set of all the points inside of the figure, like this. All these points, right? Exterior is the outside ones. So that's why we're saying the sum of the interior angles in the triangle. Okay. An interior angle is formed by two sides of a triangle. An exterior angle is formed by one side of the triangle I don't know if this says like extension or auxiliary line. Let's say extension. Okay, each exterior angle has two remote interior angles. A remote interior angle is an interior angle that is not adjacent. Okay, that was a lot. Let's look at this picture. All right, you see this cute little angle 4? Okay, it's formed by one side of my triangle and the extension of a second side. I just extended the side and I made an exterior angle. Okay, we kind of talked about this for a second ago. Oh, geez Louise. There we go. Okay, so these two angles, angles 3 and 4, are adjacent. They are also a what kind of pair? Because they are a what kind of pair? Starts with an L. Yeah. Remember we had that thing where all linear pairs are adjacent, but not all adjacent angles are linear pairs? Okay. Okay, so they are, as you said, supplementary. Okay, what do the measures of the interior angles of a triangle have to add up to? 180. So angle 3 with angle 4 is 180, and angle 3 with angles 1 and 2 is also 180. What can you tell me about 1, 2, and 4? Correct. Because 3 is in both little equations. 3 and 4 add up to 180. 1, 2, and 3 add up to 180. Then 1 plus 2 has to be 4. You guys with me? Okay, perfect. The measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. Okay, when you use a remote, you're far away from the TV. It's not called an adjacent. Like if you're adjacent to the TV, you just push the numbers. TVs don't even have that option anymore. When I grew up, you could actually push the numbers on the TV. That's how we'll win it. All right, so I can say the measure of angle 1, whoops, just kidding, the measure of angle 4 equals the measure of angle 1 plus the measure of angle 2. Okay, so we're going to use the exterior angle theorem. We're going to find the measure of each specified angle. So, if this lovely angle is 120, what's this angle? This one. It's 70. Because this angle plus this angle have to add up to this one. Okay? I don't know that this is the most important theorem that we'll ever see, because you can just use the triangle sum theorem and linear pairs and get the same thing. So some of you were yelling out 60. Why were you saying 60? That one's 60, right? Okay, now how many do I get in my triangle? 180, I've used 60, I've used 50. How many are left? 70. So the exterior angle theorem is a shortcut, but only if you can remember it. So if you can get the same result by remembering linear pair, by remembering the sum of the interior angles of a triangle is 180, then like, who really cares? Just saying. Just saying. When I was going through these notes, I was like, oh, I forgot that was a thing, because I just remember the other two. Just saying. Some of them are more important than others. All right, what about this guy? So here we have an exterior angle. Okay, this is the little adjacent, and these are the remote interiors. And this is the exterior. So what do we know about the sum of the remote interiors? Yeah. So I know that 2x plus 3 plus 15, here's one, here's the other, has to add up to 5x minus 60. Okay, then we can obviously solve for x. All right, let's do that really quick. Okay, 3 and 15 give me 18, so I've got 2x plus 18 equals 5x minus 60. Okay, I'm going to subtract over the 2x. Now I have 3x. Add the 60 over. Now I have 78. That doesn't look right. Did I mess up? Okay. Maybe 78 is divisible by 3. What do I know? Oh, it is, because 7 and 8 plus 15. Do you guys know the divisibility tricks for 3? Yeah, I'll show you in a second. So what did you say x was? 26. Okay, am I done? You got to plug it in. So it's this one. So 2 times 26 plus 3. The measure of angle B is what? Is it? 55? Yeah. Okay.